let's see here. Never forget to write. Never forget to write what? Never forget to write your math down, okay? We see, about the mole. So we finally know what a mole is now. Yeah.
I actually had a question about Avogadro.
Yeah.
Was that the name of a person, or was that like
yes, his name is Avogadro. No, I forgot his first name. Something Avogadro. It's a guy's name. He discovered that whenever you find, so if mom asks you to go to the grocery store and says get a dozen bananas, you know how many that is. How many is that? 12. But if mom says go to the grocery store and get a mole of bananas, it is equal to, a mole is a word that means a number. Just like a dozen is a word that means a number. A mole is 6.022 times 10 to the 23rd. Okay, so it's a very, very, very large number. And the reason we have to explain it as a mole in chemistry is because atoms and elements and molecules are tiny, right? So a bunch of them, it's only about yay big, it just fits in your hand, but there's a ton of them there. There are, if you have a whole mole of oxygen atoms in your hand, there are 6.022 times 10 to the 23rd of them. And so we just call it a mole just like we call things a dozen. And the guy who discovered that was Mr. Avogadro. So, and we celebrate him on Mole Day, which is October the 23rd. Why would that be October the 23rd if it's the mole? 10 to the 23rd, yeah. So you guys, if you want to take a chemistry, we have a Mole Day celebration. They'll be rocking their Mole Day t-shirts on that day. You just wait. So that is something that we'll use that term, we'll use that unit a lot. We'll use it today, and I'm going to kind of show you the different perspective about it. But should not have been the only thing you got out of that video last night, or either video. What you really should have seen is that we have this fancy way of converting from, A to B. It's called dimensional analysis. And it's a way that helps us kind of take unknown units and convert them from A to B. It helps us break down units by canceling them. It doesn't ever change the measurement. It doesn't ever change the number, really, or what it is. It's just represented in a different way. Just like 1 dozen is... Where did this go? There we go. 1 dozen equals 12 bananas. I'm going with bananas here again. Okay? Those look different, but they are the same, right? So I could easily say, if I wanted 10 dozen of something, of bananas, okay, and I wanted to figure out how many bananas that was, you could just go, oh, I know that 1 dozen is 12, so 10 dozen is how many bananas? 120. So what mathematical calculation did you do in your head? 10 times 12, right. So what did you literally do in your head, though, in dimensional analysis terms, is you did 10 dozen times 12 bananas over 1 dozen, okay? So this right here, this is a conversion factor. It is a fraction, that's used to convert. So it's called a conversion factor. And the reason you did 10 times 12 and not 10 divided by 12 is because this dozen here, we don't care about that unit anymore. We want the unit of bananas. Because I asked you how many bananas, blah, blah, blah. I asked that question. So the dozen and dozen must cancel to leave you only with the unit that you wish. Yes. What do you want to be done? Huh? What do you want to be done? All of them? You can drop Okay, so the bananas are on top. So what if I said, instead of that, what if I said how many dozens, or dozen, part of a dozen, are 10 bananas? Is that a full dozen? No, you already know it's less than that, right? But how would I set up the conversion factor for this problem if I'm asking how many dozens is this equal to? Do I set this up the same way? Or do I flip it? You need to flip this because the dozen is what I'm asking for. I'm looking for that unit. That must go on top. 1 dozen and 12 bananas. You already knew that 10 bananas wasn't 12. You knew it wasn't a full dozen. So 10 divided by 12 is like 0.83. So this is a new way of mapping it up in there. Okay, that's basically what dimensional analysis is. All about units, so you must write units on everything. And it depends on what you're looking for as to what unit you leave on top. So let's start some, and I want you guys to kind of give me feedback on how you're feeling about it. Because we have a bus drill today, and I want to make sure that you get taken care of before we go there. Okay. Okay. So this is, with me, some of this is on the lecture notes that I printed out for you. This particular information is not, but eventually we're going to practice questions from there, so just go ahead and grab that for me. It's the lecture notes sheet, and we've already done half of it. We're going to take that today. So, this is my favorite. Everyone's like, dimensional analysis. That's what we're working on today, okay? It's some fancy word for math and units, okay? So let's get some background information, and then we'll kind of move on to more bigger problems. All right, you guys ready? Been settled here? Okay. So, like I said, dimensional analysis is all depending upon having a conversion factor. A conversion factor that we have dealt with before is density. How is density written in terms of its units? Grams over milliliter or volume, right? I'm going to go with milliliters for mine. So, like, for example, the density of water is 1. This is a conversion factor. And we can write this in many different ways. We have lots and lots of units in chemistry, so I want you just to get familiar with some of them. Like grams per milliliter, grams per mole, because, like I said, my mole of oxygen in my hand, how many of them are there? How many oxygens? Such 6.022 times 10 to the 23rd. So I have a bunch of oxygens in my hand. They weigh something, okay? They do. It's matter. It matters. So it's going to weigh something. That's why grams per mole is going to be a common unit we use. Another one is not JK. It's joules per Kelvin. That's what the J stands for. So, and I'm going to expose these to you a little bit every day. You'll kind of learn what they relate to. Joules is a unit of energy. Like a calorie is a unit of energy, joules are a unit of energy. So, our main goal in dimensional analysis is to set up fractions and multiply a bunch of fractions together in such a way that we are able to cancel units, as what I was just doing here. You cancel anything that's on the top of the numerator or in a fraction, you can cancel it with the same unit in the denominator of another fraction. So you have to write a lot of fractions in this one. And 2 days ago we talked about the metric system. So I'm going to use those a little bit today as we go through, so that you're practicing both of them together. Because I know that you know that 1 kilogram is equal to 1,000 grams. And these two things are equivalent. So that's essentially me saying 1 kilogram is equal to 1,000 grams. And if these two things are equivalent, I can write them like this as a conversion factor. Because all conversion factors, the numerator and the denominator, they're equivalencies. So this one's easy to see because you know that 1 kilogram is 1,000 grams. You know that 1 gram of water is 1 milliliter of water. Some other ones you may not know is water's mass is for 1 full mole of water, it's 18.02 grams of it. That's not something you have to know though. Like I'll tell you conversion factors, I just want you to see that it is a conversion factor. They are equivalent. So if these two things are the same, what is the quantity of this number, of this fraction? If this numerator and this denominator are exactly the same, it's 1. All conversion factors are 1 because they are equivalencies. So that's why we use them, because we're not really changing the number. We're not really changing the measurement. We're just changing the way it looks. We're giving it new units. We're giving it a makeover. That's all we're doing. But we need to be comfortable with that. We need to know our units fairly well. So let's start with an easy one with density. In a problem, you are always going to be given a conversion factor. You just have to hunt for it. And the way that you hunt for it is really you're looking for something with a division symbol in it. Okay? So in this question, in this example, I'm telling you the density of aluminum is 2.7 grams per centimeter cubed. So that is the conversion factor. And I can say it like in words too. The density is 2.7 grams per 1 centimeter cubed. And that per means divide. So I can give this to you in words or in a fraction like that, and that's your conversion factor. In a problem, you also will always be given a given. So it's usually like a piece of data. It's usually like a single point. And in a problem, you will be always asked a question. What's my question in this one?
How many grams?
How many grams? I'm looking for grams. So every time I do a word problem or something like this, I look for those three things. The starting point is my given. The question, and I write down the question mark with the grams because I don't want to have to read how many grams. I want to see that I'm looking for the unit of grams at the end. And I look for the conversion factor. So every time you do a problem like this, you always want to start with your given and convert. So I'm going to kind of slow down here. I'm starting with my given of 40.0 centimeters cubed. I'm going to convert just like I did over here by multiplying conversion factors together. So the goal here is to get rid of centimeters cubed and get what unit? Grams. This conversion factor here, I like to write it as it's supposed to be as a fraction. So I'm going to write that up here. 2.7 grams per 1 centimeter cubed. How did I know it was 1? Because there's nothing there. Assume 1. Okay? Assume a 1 if there's nothing there. So this, I can actually just take that and place it right here. And do I take it as is, or do I need to flip it so that I can cancel out centimeters cubed? As is, because the centimeters cubed is already in the denominator. So if I take this centimeters cubed, write it down here, take the 2.7 and write it up here, you'll see that I have centimeters cubed in a numerator on one fraction, and this is kind of still a fraction because it's over 1, but nobody needs to write over 1 because we should be able to see that it's a numerator by itself. Centimeters cubed and centimeters cubed will cancel here because there's 1 in the top and 1 in the bottom. What unit's is the only unit left? Grams. So, is that answering my question? Yep. Continue. 40 times 2.7. Yeah, everybody have a calculator? Or a phone? Sorry. Forgot to pull those out. If you don't, there are a couple behind Morgan. There's a toddler's room right there behind Morgan. You guys can grab one. Or say, Morgan, pass me a calculator. Morgan, can you pass me a calculator? Just make sure they go back in the bin. So, what did you guys get when you calculated? 108. All right, and then your keen eyes like, oh my gosh, she's got it to wrong sig figs. How many sig figs should be in this problem? 2, because this has how many? 3, and this one has 2. So round. What is it? No, 110. So don't forget when you're rounding, you always start from the left and move to the right. So you see that you have to record the first 2 significant, or those 2 digits as sig figs. But you always got to double check. The next one, it's an 8. It rounds the 0 up to 1. So 110 grams. Final answer. Okay, so this is called dimensional analysis. Using conversion factors as fractions to cancel units in an effort to get a new unit. It sounds like a lot, but if you see the units and you can cancel them, you should be in good shape. So, similar question, what is my given? 40.0 grams this time. What is my question? Much. What is that? Much space. What unit is that looking for? Space is volume, right? So centimeters cubed, yeah? So sometimes you have to interpret what I'm asking, but you can figure out which unit that is. What is the conversion factor I gave you in this one? I know it's not here, it's on the top of this. 2.7 grams per centimeter cubed. Okay, so that's our conversion factor. Okay, so taking this gram, I know I don't want grams. What do I want? Centimeters cubed. I'm going to go and put that on top. I know I need centimeters cubed on top, and I know I don't want grams, so how do I cancel grams? Put grams on bottom. Now, what number in my conversion factor goes with centimeters cubed? Goes with centimeters cubed. 1. You see that imaginary 1? Okay, 1. And what number goes with grams? 2.7. So, 40.0 divided by 2.7. What you got? 14.9. 8 units. Did we cancel them? Cancel them right now until you get the hang of seeing them. You see the gram here, cancel with the grams on the bottom, leaving us only with our unit of centimeters cubed. Yay! Okay, so centimeters cubed. Final answer? No. What is it? Okay, so good. So you're looking at sig figs. You see 3 sig figs in this question. Now you don't even have to you may be soon to the point where you're like Pacific, Atlantic, present, absent, you're starting there. You might be able to start looking at questions or problems. You're like, oh, that's got 3 sig figs. This got 2 sig figs. And then I need 2 sig figs. So you're getting good at it now. And you see that 14.8, the 8 rounds the 4 up to 15 centimeters cubed. Okay, so far, okay? Give me some shakes or like scary faces, anything.
So you just not going to with the one, like move the measurement to the same thing?
Good question. The 1 in this case, what you're doing in your head or calculator is 40 times 1, because all the numerators are multiplied by each other, and then technically all the denominators are also multiplied by each other, but all the numerators are divided by the denominator. So it's 40.0 times 1 divided by 2.7. And I'll go through that more. Okay, look at these crazy things I've given you. What are these? Conversion factors, right? Because it's just a fraction. I could give you 4 puppy dogs are equal to a dinosaur. It doesn't matter. I told you it's conversion factor. So these are conversion factors because I've listed them as fractions. So these are tools you'll use after you know your given. So looking at my first question here, what is the given? 40 grams, right? So starting with your given of 40 grams, and this is water because everything here is pertaining to water so far. My question is moles, right? MOL is moles. Is there a conversion factor with both grams and moles in it? Given to you here. Yeah, what is it called? Molar mass, right. So I'm going to take that conversion factor and use it for the problem because it's just the specific conversion factor I need to help me get through from grams to moles. So I'm going to take this and write it how? What goes on bottom? Good. You're seeing that this 18.02 grams, the 18.02 sticks to the gram. Right. Don't separate those. They stay together. Why are we putting the grams on bottom? To cancel these grams on top. Good. But what goes with mole? 1. Because this is a fraction, so it's 1 mole. So in your calculator, what are you doing? So 40 times 1 divided by 18.02. And do not times by 1 in your calculator. You know it's the same. What did you get? 2.219 moles. How do I know moles? Right, because after you've looked and you're like, okay, grams on top, grams on bottom, only unit left that has not canceled is moles. Okay, so you met your goal of moles. This is still not all the way correct. Okay, how many sig figs? 3, because this one has 3, this one has 4. So I need to round this to 2, 2, good. Because I need those 2, and the 9 rounds the 1 up to 2. Yeah. Down right here.
No, like disregard the problem.
Okay.
Number the 2.219 didn't have a decimal. How would you get like what I'm trying to ask?
You would have done if it was 2,219 and I wanted to go to 2 sig figs. I mean 3 sig figs.
Yeah.
Then I would have written it as 2,220.
Okay.
Because there's still only 3 sig figs there because there's no decimal present. I feel like I can read your mind, so I can figure out what your questions are. Sometimes you guys can't read my mind though, so if I'm not saying something clearly enough, please let me know, because I can modify the way I explain something. Okay, let's try another, oh no, I forgot the one I wanted to do. It's on the bottom of the screen. My bad. This one. Okay, so I'm going to pull this little question up so you guys can see all the conversion factors. You guys can see the question is molecules, right? What's my starting point? Milliliters. Do you see any conversion factors with both of those units? No. So this one's harder because it requires 2 steps or 3 steps, not 1 step. So when I say steps, I mean uses of conversion factors. So I have to use the something with milliliters in it first. Which conversion factor has milliliters in it? The density. So knowing that much, I know I can get from milliliters, I can use the density and get to what unit? I see my milliliters are going to cancel, right? And I can get to grams. Can grams get me closer to molecules? Yes, but I don't have any conversion factor with grams and molecules, do I? No, I have grams and moles. So then I know I'm going to have to use this conversion factor to get to grams. I'm going to use what conversion factor next? The one below it, right? So I'm going to take my grams to moles, and then I can go from moles to molecules, right here. 1 mole is blah, blah, blah molecules. So it's sometimes nice to piece a puzzle together in your head first, and then put it on paper, so let's put it on paper now. I'm going to pull up this little thing. This thing keeps popping up. Okay, so starting off with 80.4 milliliters. And these are hard. I'm starting off with hard ones. I'm going to go back to easier ones in a second. So if you're getting this right now, pat yourself on the back, because you're feeling good about yourself. Okay, so 80.4 milliliters. I need to cancel the milliliters. So how do I take this and write this down? As is or flip it? As is. So this number, 0.9994 grams is on top. What goes with mils? 1 milliliter is on bottom. Good. So far, what has canceled? Milliliters. It's nice to scratch that off. Okay. So now I'm kind of restarting. What am I starting with? What unit? Grams. I don't want grams. What do I want? I want molecules, but I can't get that. That's too far of a step. Okay, I guess it's go baby steps. I really want grams to be on what part, top or bottom? Bottom. And what do I want on top? Or what do I have to put on top? Moles, because I'm using this conversion factor next, because we kind of already went through that. I have grams. What number goes with grams? 18.02. And what goes on top? 1 mole. Just because I'm telling you that's equivalent. Like I could tell you 5 rainbows is 1 kitty cat, right? You have to go with it. That's the conversion factor. Okay, so now what units cancel? Grams and grams, because they're on top and bottom. So now we have moles. Nobody wants moles. What do we want? Molecules. We want molecules. All right, so what goes on bottom? Moles. Mole goes on bottom. So now we're using this conversion factor. So the 1 goes with the mole, and then what goes on top? 6.02 times 10 to the 23rd molecules. MOL'(C) is molecules for me. And what unit cancels? Moles. Okay, then we're going to whip our calculators out like a champ, and we are going to calculate. Yeah. Yes, because the 1's here and 1 here, it's not going to affect your calculations. That one's not going to affect your calculations. So what I will put in your calculator is 80.4 times 0.9994 times 6.02 times 10 to the 23rd. I get all that. It's going to be a big number. And then what would you do? Oh, not yet. I have not included one thing. Yeah, you still have to divide by the denominator stuff. So whatever this is in your calculator, divide it by 18.02, because that's the only number that's meaningful really in the denominators. And that's going to be a number like what? .684 what? Times 10 to the E is times 10 to the 24th. E24 is times 10 to the 24th. Molecules, right? Because that's the only thing left here. So now you're going sig figs, Miss Enlow. How many sig figs? 3. This has 3. This has 4. This has 4. This has 3. 3 wins, right? This is just going to be that. 2.68 times 10 to the 24th. Because the other numbers were small, they didn't round up. So that was a huge one, okay? This is actually called stoichiometry. Did you guys see that in the video? Stoichiometry is chemistry math. Dimensional analysis is like the method that we're using where we're canceling. Stoichiometry is just the word for chemistry math. So we're kind of doing both. Now, this right here seems like it's kind of like, why are we doing this? When we get to big boy stoichiometry in unit 4, because we're going to kind of keep going doing this little by little, you will use this a lot. Maybe chemistry, we just did it all yesterday, so we're in still. I'm not going to do that one right now. Okay. Remember these guys? Okay. Now we're going to kind of go back and we're going to use dimensional analysis instead of decimal swoops with the metric system. So let's do a couple like that because you have some on your homework. We're going to, at the top of our paper, this is your paper now, okay? This is the notes I gave you. Write down our number line. What happened to the king? He did what? King Henry, he died. How? By what? What kind of milk? Chocolate milk. And then he microed, and then nanoed, and then picoed. Okay. And before that, he megaed. Okay. Yes, I gotta entertain myself if you guys are gonna entertain me. Okay. These are decimals, which are placeholders for zeros. Those dots mean something. Okay. So keep that at the top of your paper. You're gonna use it. I know you can decimal swoop, but I want to see you dimensional analysis. Let's do number 3. I'm only gonna do a couple of these because I want to see where you are. Some of us get it, some of us don't, so I get everybody caught up here. Starting with this one, write down your given, 84345.6 micrometers. Set this up just like we did our previous problems. Now, what is our question? What is our unit of interest? Meters. I'm looking for meters. That's my question. I need to multiply by something. I won't put the numbers in there yet. Let's just throw units up here right now. I need to multiply by something to get what on top? What's my desired unit? Meters on top. And I need to cancel micrometers, right? So where do they go? Denominator, right. Okay, so step 1, given. Step 2, write units to get what you want on top and cancel what you don't want on bottom. Step 3, look at number line and tell me which unit is a larger unit. Meters, right? Meters is at the base. What else is at base? Meters, grams, and liters, right? Don't forget that. That is base unit. Okay. So 1 meter is a ton of little bitty micrometers. But how many is a ton? How many zeros or spaces away is base from micro? 6. 1, 2, 3, 4, 5, 6. 6 zeros away, right? That's not 6 times greater. That is, 10 to the 6. Yeah, it's not 6 spaces away. It's not 6. It's like 10 to the 6, right? 10 to the 6 micrometers in 1 meter. And that makes sense. 1 huge meter has lots and lots and lots and lots, a million little micrometers. So I know you can do this on a calculator. I know you can do this in your head. Basically what you're doing is this number divided by 10 to the 6, and whenever you divide by 10 to the 6, it just moves the decimal back 6 spaces, right? So I'm practicing dimensional analysis, this new concept, with something that's like super easy to show you that you can do it both ways, but I'm getting you to start doing it this way so that you can have skills later on. So this is 8.4345.6 times 10 to the negative second. 7. You can do it either way in your calculator. Basically, this is going back 1, 2, 3, 4, 5, 6. So it's back. Oh no, I was right. 2 seconds. Meters. And what units canceled, by the way? The micrometers. Very good. Meters are yeah, you can write it as .08, blah, 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 or in scientific notation. Either way works. All right, so that's a simple one. That's just metric system, number line. And I will note this now because I will forget later. I know that you're looking right there and you're going, so she forgot sig figs, right? How many sig figs are in these numbers? 1. Every single metric problem you do will only have, it'll limit you, it'll look like it limits you to 1 sig fig. Ignore the metric numbers for sig figs because the metric system is a prefix system. It's not really a measurement, right? The prefixes that we're talking about, micro and this base unit, it's more for like scale than number of sig figs. So I always refer back to the given for sig figs, and that's why this answer is in 7 sig figs, 6 sig figs. Okay, let's do one with a fraction within it. Like, let's do number 5, okay? Okay, and I'll give you guys a break in a second, okay? Write down your given as a fraction versus like a slash mark like that. And multiply. Now, from our question, what can you see is changing? What unit? Meters to what? Centimeters. Seconds, 2 seconds, nothing changes, right? Ignore that seconds are even there for the moment and tell me, I need to cancel meters, right? So what do I do on my next part? Meters on bottom and what on top? See, I'm going to centimeters per second, right? So I'm taking meters to centimeters, so centimeters go on top. What was your next step? Decide which is the larger unit, right? Which is the larger unit? Meters, it gets a 1. How many little centimeters are in a meter? 100, and you know that because, in case you don't know that, where's my number line? Oh. Okay, you know that because meter, which is right here in the middle at base, 1 is 0, 0, 100 away from centi. So don't forget, you put a 1 there, and then you write zeros after that. Okay, so all you're seeing now is that meters and meters cancel, seconds stays, centimeters stay. So what's my final unit? Units? Good. And so then 88 times 100, 8,800. How many sig figs in our final problem? Answer. 2. And there were 2 to begin with. Like I said, the given and the given. I mean the sig figs final. So here's our final answer. So just notice the seconds are kind of ignored because they're not changing, period. Okay, number 6. 4.52 grams per milliliters. What is changing on the numerator? To what? Kilograms. So you see grams to kilograms. Is there another change? Yep. We also have to consider the denominator because it is changing from milliliters to liters. But we can't do both at once. Let's just do the numerator first, stop, and then do the denominator. It's just going to be backwards. So ignore the milliliters for the moment. I need to cancel what unit? Grams. And I need to get it to what unit? Kilograms. Larger unit? Kilograms. And it gets a what? It gets a 1. How many grams are in a kilogram? 1,000. You just know that probably, but you can also double check on the number line. K is 3 away from base. So 1,000. So 1,000. Okay, so what cancels so far? Grams and grams. Good. All right, so we reset. Do you want to cancel the kilograms? No, you need it. It says I need kilograms on top, so I'm going to circle that just to remind myself I keep it. Don't cancel. And I need to take this milliliter to liters, right? So this milliliter needs to cancel, but how do I cancel something in the denominator? by moving or adding it to the numerator, right? So I'm going to multiply it by milliliters on top here, and it's okay, you know, they're far away, but whatever. They're still top and bottom. Cancel those. What has to go in the denominator? What do I want in the denominator? Look, liters, right? Because it's liters in the denominator. I know. Sometimes when you write it side by side, you have to kind of like flip it to see that's top and bottom. Okay, so now you've got your next conversion factor. Which is bigger? Liters is a bigger unit because it's the base unit. How many millis are in a liter? 1,000. So base is 3 away from milli. What happened in this problem? Mathematically, what happened? Okay, milliliters do cancel. You're right. Mils and mils. Liters, kilograms, and liters are left. Those two units. Mathematically, though, the thousands also cancel, right? It just so happened in this problem we have one on top and one on bottom. So the answer numerically is actually the same. The units changed. So if you were really good, which you would have seen to begin with, was a gram and a kilogram are 1,000 apart, and a milliliter and a liter are 1,000 parts, and they're moving the same direction, so they actually end up canceling. Dun, dun, dun. Okay, so that's just a good practice because you're familiar with those units. Okay, take a 1-minute break, get up and see somebody, talk about whatever. I'll leave this here for a minute, let you have a mental break. Can you get up and do yoga? Sorry, I'm pushing you today because we have to be done by 1:50. It's 3/4 oil. So this is all oil. It's like I understand it, but it's a lot to process.
Okay, what'd you get?
I'm not good. You guys want to see gold? Some gold.
What's the other one with the little rainbow?
Those are my embryos. That's what I tell everybody. They're water marbles. Oh, no, do not take it. It's led to iodine. It's carcinogenic. It stays in here. Okay. Is that ready to start back? Yes, Miss Hello. Okay, great, guys. Okay, go back to your seats for me. Go back to your seats for me. Go back to your seats for me. Thank you. Gotta give you guys a break. Don't abuse it. All right. So let's do. I skipped. You'll notice on your lecture sheet. What did I skip?
Skip two-step conversion.
I did, because you don't need to do two-step conversions unless you feel the need to take a break at the base and then move on. So if you really wanted to, could you go from decimeters to megameters? Yeah, you're going from decimeters to megameters by saying, which is the bigger unit, mega or deci? Mega. Mega is like 7 spaces away from deci. 7 0, so it's 10 to the 7th difference. So you don't have to stop at base. You can keep going, keep trucking, okay? So I'm not going to do the, well, do I need, I'm not going to do that right now. I'll come back to if I need to. These are the harder of them because you require an extra thought of cubing or squaring. The rule is, and put a star by this on your paper, I think did I write this for you? In your paper?
Wait, conversion factors must be split.
Yes. So whenever you write a conversion factor for a problem that has a unit like this, that's continuing its cubedness or squaredness or whatever it is, it needs, the conversion factor that's converting it also needs to be cubed or squared. So for example, I'm gonna kind of show you where we ignore this cube squared part and then we're gonna continue. Write down your given. Yeah. I'm not that mean. Okay. So that needs to take meters cubed to centimeters cubed. I don't know that conversion though. What do I know I know meters to centimeter conversion. Yeah? So for a second, scratch or ignore your cubeness. And this one too. And I need to cancel meters. Meters goes on bottom. I want to get to centimeters. Centimeters goes on top. Which is bigger? Meter. How many centis in a meter? 100. And you go, oh, hey, this thing's got to be cubed. Cubed. That's not talking to myself in my head. Okay. So when I cube a conversion factor, literally everything in here is cubed. So 100 is cubed. Centi is cubed. 1 is cubed. Meter is cubed. Okay, you can add it in there like that if you want to. You can keep it on the outside if you get that it distributes in. But I'm just going to keep it like this for now to show you that the units do cancel. What unit cancels? Meters cubed. Meters cubed. Okay, what is 800.4 times 100 cubed? What is 100 cubed? 10 to the what? What's 10 squared cubed? 10 to the 6th, right, which is a million, right? Okay, so 800.4 times a million, 800, 400, thank you. I don't like that many zeros. I'm all about that scientific notation, and you'll see most of my answers are recorded that way. What is that, 7, 8? So it's not a totally different problem. It's just a problem if you forget the cube part, or squared, or whatever it is. Okay. Can I move on? Okay. I see some people shaking their heads, some people are like, what have I signed up for? Okay. These are complex. I'm going to do one of them. We kind of just did one where it was like 2 units changed to 2 different units whenever we were doing fractions on an early problem. But the only one I want to do is D4, if I can get it to stay here, because it's got information, new units here and a squared unit here. So complex ones require you to look at only numerator and then only denominator separately. So let's do number 4, $824 per yard squared. So like if you're making a pretty dress, you buy it by squared yard. Okay. I see 2 changes happening. I see dollars to what? Cents, and then yard squared to feet squared. So I know the conversion from dollars to cents, right? So a dollar is 100 cents, right? What is yards feet? Right, 1 yard is 3 feet. So these are the equivalencies that we'll write as conversion factors here. So let's do numerator first. Sister agree? Numerator is cool. Let's go this way. $1, 100 cents. Okay. What cancels? Dollars. Now I need to cancel out, ignore the squared for a moment. I need to cancel out what? The yard. Do I put it on top or bottom? Top, because it's currently on the bottom. I need to transfer and convert by putting it on numerator here. And what goes on bottom of it? Feet. And now let's put our numbers in. 1 yard is 3 feet. And then you're like, oh yeah, it's squared. So with your calculadora, you're going to, sorry, yard squared, oops. Yard squared and yard squareds cancel. What are you putting in your calculator? Thank you, Jill. 8.24 times 100, okay, which is 824. Divided by what? So 9, yeah. So 11 something. What is that?
I got
Oh, sorry. 11. What is it? 90.
91.5.
5 repeating. Final unit. Units. Sorry. Cents per foot squared. Okay. So this fabric cost 91.55 cents per foot squared. That's not bad. Pretty cheap fabric. Okay. Sig figs. Ignore the, remember like I said, the metric ones ignore. These go with your original. How many sig figs are in your given? 3. So we want 3 sig figs for our final. Only because this is like kind of related to metric kind of conversions. So this would be 91.6 cents. Good. Per foot square. Okay. We have 15 minutes. Yeah.
I got a little bit lost when you squared, or like, where'd you get the 3?
This is kind of like one of those known things you guys know. 1 yard is 3 feet. 1 mile is 5,280 feet. Stuff like that. So that's not something I mean, I can give you those, but I'm expecting you guys to know some equivalencies. Like a dozen is 12. So, yeah.
Will this be on the quiz?
No. Just that stuff I had earlier. Yeah. So what I'd like for you guys to do is, on your lecture sheet, there's more practice, right? Please stop talking while I'm talking. On your lecture sheet, there are 5 word problems on the bottom, 10 through 15. You see them? Circle them. You're working on those right now. And I want to show you how to do one of them, at least now. And then your homework is to do problem set 3D. So I'd like to finish the word problems in class so you guys don't have to do this at home. Our class is just cut short because of this bus trip. So, looking at 10 through 14. 10 through 14 is, I'm going to leave number 15 for you guys to at least try. You guys tell me which one you want me to do by looking at them. I'll model 2 of them if you want to. 15, I plan on you trying it, and I'm going to do it for warm-up tomorrow. I got plans. Okay, you want me to do 14? Okay. Okay, let me do 10 and 14. All right, deal. I love these things. I do these all day. Oh, I already have this written down. I want you to have a highlighter or something colorful. Oh, I'll show you my joke in a second. Oh, no, I forgot to erase this from last period. No, don't look. Okay, highlight or something colorful, because I want you to prove to yourself that you can do a word problem the same way we've been doing all these other ones. What were the 3 things I told you I'd always give you in a problem? Given. Okay, stop. Let's look at this problem. What do you think the given is? Remember, the given is a fact. It's a fact. It's a starting point, though. All right, backtrack. 3 things I told you I'd give you are given, a question, and conversion factor. Yes, a conversion factor has a fractional unit, right? So this is the conversion factor. That is the biggest mistake. People are like, oh yeah, I should start with 11.3 grams per milliliter. No, don't start with that. That is a tool you're using. What is the question? So stop, don't even read what is the mass mean mark, put question mark, grams. Because you know mass means grams, right? So you're looking for, in the end, your unit should be reported as grams. Like you could even say like grams, because you know you're going to have grams at the end if you want to. And then what is the given?
45.
This is the given. And that's your starting point. Given is your starting point. So, what do we start with, guys? There you go. It's nice to dissect a problem before you begin, because if not, you're like, I read this problem 50 times, and I still don't know what I'm doing. Break it down, okay? So, you're starting with 45 mils. Then, what do I get to use? The conversion factor, right? As is, or flip it. Your choice. Okay, because I need to cancel what? Right, so I need to write the 11.3 grams on top and the 1 milliliters on bottom. Am I to my desired unit? The question. It's yes or no. Thank you. Yes. Because what can I do? Yeah, cancel the milliliters. You're like, dimensional analysis is the bomb. You can use it for all kinds of stuff. This is a number. That is written someplace. You guys tell me again.
508.9.
Thank you. You're faster than I am. 508. Sweet figs. Round me. 510 grams. Not bad, right? All right. Now I can do the hard one. Number 14.
I have a question.
Yes.
Where do we get the 2 sig figs from?
For this particular one, this one has 2 measurements kind of given to you. This one has 2 sig figs. This one has 3 sig figs. The weaker one is 2. Stick with 2. Yes.
So if there was like 4, 5, 5, 5, 5, so there was more sig figs than the other one, then there'd be 3 sig figs?
Yeah, this would be our limiting one. Only because that is a measurement. That's not really metric stuff. The metric conversions are the ones that are always going to limit each to 1 sig fig, so I didn't say anything more than that front. Okay. 14 is longer. Okay. Let's dissect. Like you can even don't even pull your calculator yet. Okay. So amount and I'm giving you questions like these to prove to you that you don't have to understand all the chemistry behind it. You have to pull numbers out and put them in dimensional analysis. That's it. And then we'll get to the chemistry later on. So what amount of heat is given off when water? I'm sorry, Li. This amount of heat is given off when water condenses. This. What is this? Some conversion factor. And remember, joules is a unit of energy. Mole is a big amount of stuff. So we have a conversion factor. The molecular weight of water is this. What is this? Another conversion factor. Right. You can use multiple conversion factors. Boom, boom, right next to each other. What's the question? So question in kilojoules, right? So I'm asking you how many kilojoules is given off when given 15 grams of water condenses. Who cares about the water condensing? These are the four things I'm concerned about in this problem. All right, so what do I start with? 15.0 grams. All right, nobody cares about the gram. I want to get rid of it. How? Right, why that one? Because it has a unit of grams in it, right? The other one doesn't even have grams in it. I can't even use that one yet. Write it as is or flip? Flip. So what goes on bottom? 18.0 grams. 1 mole goes on top. Cancel, cancel. It's like mini victories when you get to cancel, okay? All right, what's our next mini victory? Cancellation of what? No, I gotta get grams. Moles, right. So check, I've used that one. Check, I've used that one. What's my next one? Good. 254 kilojoules on top. And the 1 mole on bottom because I needed to cancel the moles at this point. So far I've canceled grams. And now I can cancel moles. And then I double check. I stop for a second. I'm like, what's my question again? All right, so nobody cares about like the word question. What unit am I looking for? Kilojoules. Am I there? Yes. Done. 15 divided by, or sorry, you can do all the way across. 15 times 254 divided by 18.0.
211.
What? Kilojoules? Okay. Sig figs? 3, 3, 3, 3. So 212. You guys are getting good at rounding because sometimes you have to take something and round it down to 20 when it's still 200. So you can do it. All right, do you feel a little bit better about dimensional analysis? Okay. We still have about 10, 12 minutes. Get the rest. 2, 11, and 12. Try. Ask me for help, and then start concept 3D. Try 15. We'll do 15 tomorrow. I'm coming around. Let me check. Sign out on the way out. Please. Oh, and I should probably take attendance. That thing, forget.